Bonjour tout le monde. My name is Frédéric Cherki, and I would like to give you a project update on project C3, Stormwater Control Measure Performance. This project is also known Mine for Stormwater in Europe, and you may better know this project as the low-cost monitoring project. So, why do we need low-cost monitoring? First, all WSUD are deteriorating. They are deteriorating because they are aging, so it could be clogging of the infiltration system, it could be accumulation of sediment, but it's also deterioration due to animals or misuse. Maintenance is needed as any asset. For now, most of the maintenance of WSUD are based on corrective or run-to-failure maintenance, meaning that we will wait for the failure to happen before taking an urgent or deferred action. The best will be to move from corrective maintenance to preventive maintenance and act before the failure. One way to do that is to organize scheduled inspection and go, for example, go and inspect WSUD every 6 months. But these scheduled inspections are also blind inspection because you don't know if you need to go and inspect when you are going in for the inspection. You may arrive too late, so after the failure, or you may arrive in a situation where the asset is in good condition and no inspection was required. One other way for preventive maintenance is to base the maintenance on the prediction of the condition of the asset. In this case, you need deterioration model of each asset, and you will base your inspection on the predicted condition. But this is very difficult or impossible for now for WSUDs because we don't have enough data to build accurate condition deterioration models. So one other way will be to monitor in continuous all the assets. And if we are always monitoring the assets, we will be able to detect any failure before they happened. Of course, continuous monitoring will increase the inspection cost of the assets, but avoiding failures from assets will decrease the impact and rehabilitation cost of these assets. So keep in mind that rehabilitation cost and impact of cost are much more expensive than inspection costs. So the continuous monitoring is a good solution. Monitoring means also to know how the system will behave in different situations. During the dry weather, does the system remain dry as it should, or does the water level stay at the normal water level for a wetland? And what happens during a small rain event, medium rain event, or a much bigger rain event? All these situations must be known. So the idea of low-cost monitoring is to inspect more assets more often, and if possible with a better resolution, that is to say with more monitoring points for bigger assets. So all this project is about low-cost monitoring, and low-cost monitoring seems to provide different benefits such as open source code that can be shared, cost-effective solution, high modularity with the possibility to plug many different sensors based on what we need to monitor, but also low power consumption for systems that will last longer in time, and low-cost monitoring system often enable real-time access to data. They have some drawbacks like extra time and expertise needed to design and set up the system, but the main concern is often about the reliability and longevity of this system. Low-cost products are often said to be not reliable or not robust enough to last long. So we decided to inspect also this aspects. So what has been done? We have investigated the whole monitoring chain. And so we have searched different boards and investigate costs, reliability of boards, and the way the board can be programmed. We have investigated the possibilities of sensor with cost, reliability, and performance of sensor. We have looked into the integration chain, meaning what component can be put together on the same monitoring system. We have worked also on the system autonomy, battery size, working time, and the use of solar panel. We have investigated different communication technology for the availability, the price, the bandwidth, the range, and we have specifically looked into low power wide area networks such as LoRaWAN or Sigfox. We have also connected this monitoring system to a platform to access data, visualize the data, and store it. And we have also worked on interaction with the monitoring system for remote control and for alerts. The first thing we have worked before building prototypes was to work on the performance of the sensor itself. So we have investigated different water level sensor, low cost water level sensor. And so we have assessed for each low cost sensor, its range and its accuracy. And for the sensor that were better suited for our monitoring expectation, we have worked on optimizing their use in order to have the best precision possible and to reduce the sensitivity to the environment. Then we have worked on building prototypes. So we have built a few prototypes meant to monitor the water level in wetlands. These prototypes are autonomous. They have battery, solar panel, and they are monitoring the water level in the WSUDs every 15 minutes and sending the data for real-time access on the platform. We have developed few of these prototypes and we have tested them and then deployed them on different Melbourne water wetlands. And we have deployed them a few months ago, and we have been successful in make them being autonomous and sending the data alone. So now that we have the first monitoring system, and we know that we can do monitoring system and they can be reliable and they can be robust, the idea is how can you use these outcomes? So the first thing is reducing monitoring cost will help to install more monitoring on different WSUDs of the territory, different wetlands or other WSUDs of the territory in order to gather real-time information. This real-time information can be used to develop alert system. You can have alert system that will be triggered on low level, high level, or for wetlands if there is a backflow or if there is no inflow. And you can also develop alert system that will alert you when the monitoring system is not working. So you can receive an alert if there is no new data or if the battery is lower and need to be changed. This, at the end, aims to improve the maintenance. And as I said in the beginning, the main idea is to move from a corrective maintenance to the preventive maintenance. And if we can improve this maintenance, then we will be able to decrease the cost of maintenance of this system. But that's not only the purpose of the monitoring of more assets more often with a better resolution. If we have more data on the behavior of our system, we will improve the knowledge that we have on these assets. So we will improve the model, for example, for the infiltration. We will also improve the methods to maintain and design these assets. And then we can also work on improving the tools to design these assets. If we have some feedback on the difference between the design and the real operation of this system. And as Matt will say, the data is very important. So that was the update November 2020 of the project C3. Thank you very much, and feel free to contact me if you have any question.